Welcome. Today we take a new chapter, increasing and decreasing function. So let us see if a function y is equal to fx is given when it is increasing, when it is decreasing. Let us try to explain with the help of graphically. Suppose this is a function y is equal to fx. So this point is say x is equal to a, that point is x is equal to c, that point is x is equal to d, and say it is b, say. Now it is clear that as x moves from a to c, this is our x, f of a, this is our f of c. So as x moves from a to c, this is fc, this is fa. So fc is more than fa, so the functional value increases. In general, if x1 and x2 is such that x2 is greater than x1, suppose this is our x1, this is our x2, so this is fx1, this is fx2. If x2 is greater than x1, I rewrite it. If x2 is greater than x1, if fx2 is greater than fx1, we say that it is an increasing function. Similarly, for this case, from this to that is C to B, suppose this is a point, say x3, and that is a point, this is x3, that is x4. So if x4 is greater than x3, x4 is more than x3, and in that case, if f of x4 is less than f of x3, that is, as x increases, functional value decreases, then we say that it is decreasing function. Now, how to identify where the function is increasing analytically? So, in any point over A to C, if we draw tangent on the curve, it is clear that it makes an angle, makes an acute angle with x-axis. That is, if it makes an angle theta with x-axis, tan theta is positive. That is, tan theta means derivative there, that is f dash x is positive. If f dash x at any point or at any interval, if it is positive, then we can say safely that the function is increasing at that point or over the interval. Similarly, if at any point or at any interval, if f dash x is less than 0, then we say that at that point tangent of the gradient makes an obtuse angle. If obtuse angle, then tan theta is negative. So if f dash x is negative, at every point you see tangent makes an obtuse angle with x-axis. Okay, then f dash x, if it is f dash x is negative, then the function is decreasing at that point or over that interval. So, so only thing we have to keep in mind that to identify whether a function is increasing or decreasing, find derivative. If at that point or in that interval f dash x is positive, then it is increasing there. If f dash x is negative, then the function is decreasing there. So this chapter problems are very straightforward. By taking few examples, let us discuss the discuss the problems. One more thing, if in an interval, say a to b, f dash x is greater than 0, then we can say that it is strictly increasing from a to b. And if it is greater than or equal to 0, we say that this is increasing. And similarly, if f dash x is negative there, only negative, then it is strictly decreasing in that interval. And if this is the case, then it is simply decreasing. Now, take the first problem. If x is positive, then the function f(x) is equal to x minus 1 e to the power x plus 10 is increasing. Is four options are there. If x greater than 0, f(x) is equal to that function is first option increasing, increasing. Second option is strictly increasing, decreasing, or strictly decreasing. What is the case? So f(x) is given and one interval is given. Interval, what is the interval? The x is positive. For that purpose, let us find the derivative f dash x is equal to, its derivative is 1 into e to the power x plus x minus 1 into e to the power, derivative of e to the power x is e to the power x. It is constant, derivative is 0. So that it is equal to x into e to the power x. Because e to the power x minus e to the power x cancels. Now, it is positive because x is positive, so this part is positive, and e to the power x is greater than or equal, greater than 0 always for all values of x, so that the product is positive. So derivative in that interval is positive. Therefore, the function strictly increases there. So this option is correct. Next. Our next problem. The interval where f(x) is equal to 2x cubed minus 3x square minus 36x plus 30 is decreasing. Then options are there. Options is minus 2 less than x less than 3, minus 1 less than x less than 4. Third option is minus infinity less than x less than minus 2, and 3 less than x less than infinity. So this problem is one function is given and we have to find this where this function is decreasing, strictly decreasing, and the four options are there. So only thing we have to find derivative. F dash x is equal to 6x square minus 6x minus 36, 0. So 6 can be taken common. X square minus x minus 6. Now factorize it. It is equal to, you can very easily factorize it mentally. It is minus 6, it is minus 1. So it is actually x minus 3 into x plus 2. You see, the product constant is minus 6 and minus 3x plus 2x. So it is minus x. So this is equal to that. So f dash x is equal to this. Now to identify where the function derivative, that function means the derived function, where it is positive or where it is negative. There is a unique method. You see where the derived function vanishes at x is equal to minus 2 and x is equal to 3. Next you see, if we take x more than 3, that is x is over there. So if x is greater than 3, this is positive, this is positive. So product is positive. You see, in that case, when we take a value of x less than minus 2, then what would happen? Less than minus 2 means minus 5. So it is negative. This is also negative. Product is positive. So here in that interval, derivative is positive. In that interval, derivative is positive. And within that interval, minus 2 to 3, say 0 is a point. This at x is equal to minus 3, this become at x is equal to 0. Between this and that, 0 is a point. So this become negative, this become positive. So product is negative. So within that interval, derivative is negative. So this is negative in minus 2 less than x less than 3. So in that interval, this is simply negative, not even equal with 0. So the function is strictly decreasing in the interval minus 2 to 3. So first option is correct. So that method is very helpful to determine whether in which interval it is positive or negative. So next. Our next problem is the interval where fx is equal to x into 4x square minus 3 is increasing, is strictly increasing. Options: first option is, second option is, third option, fourth option, base. So in this case also a function is given and we have to find where this function is strictly increasing. Means we have to find the interval where derivative is positive. For that purpose, find derivative. 1 into that plus derivative, মানে x into derivative of that, that is into 8x. That is, it is 8x square plus 4x square, 12x square minus 3. That is 3 into 4x square minus 1. This is derivative of that function. Now we have to find where it is positive. So this is our positive. 4x square minus 1 should be positive, greater than 1. That is x square is greater than 1 by 4. Then x lies between minus half less than half. If x is negative, it becomes negative. X square is greater than 1 by 4. So x not that. X square is greater than 1 by 4. Rather, it's just a minute. It is actually 3 into 2x minus 1 into 2x plus 1. You see? So it is now to find where it is positive. It vanishes at 2 points. One is minus half, other is plus half. If x is greater than half, say 1, in that case this is positive, this is positive. So here it is positive. And when x, in that case, in that interval, it will be again positive. If we take x is equal to less than half, that is say 0, it is negative. It is positive. No. If it is say less than minus half is not 0. Less than minus half means say minus 1. In that case, this is 0, negative, and minus 2, it is negative. So here also positive. And within that range, it must be opposite side, that sign, that is negative. Why? Take x is equal to 0. If x is equal to 0, this is negative, this is positive. Product is positive. So in that interval, it is negative. We want where it is increasing, means where function is derivative is positive, and derivative is positive for x greater than half and x less than minus half. So in that interval, it is positive. I think I have mistaken. Actually, it is given x is less than minus half and x is greater than half. It is given there. So this option is correct. Our next problem. In which of the following interval fx is equal to x to the power 4 minus 4x cubed plus 4x square plus 40. In which of the following interval this function is monotonically decreases? Monotonically decreases. And options are 0 less than x less than 1, 1 less than x less than 2, 2 less than x less than 3, and 4 less than x less than 5. It is given in WB JEE in the year 2010. So that problem is again a straightforward problem. Function is given, and to identify where it is monotonically decreases, that is where the function, derivative of the function should be negative. Find derivative. F dash x 4x cube minus 12x square plus 8x 0. So that taking 4x common, it is equal to x square minus 3x plus 2. Now to identify where it is positive or negative, try to factorize it. And mentally, very easily we can factorize it. It is 2. So x minus 2 into x minus 1. Because plus 2, it is minus, okay, this is equal to that. Where the function, this function means derived function vanishes, it is at the point x is equal to 1 and at the point x is equal to 2. As because monotonically decreases, that should be negative. If we take x is greater than 2, say 3, positive, positive, product is positive. So this become positive. So automatically this become negative. And between 1 and 2, if you take 1.5, this become negative, this become positive. So here it is positive, 1.5 it is negative, it is positive. So it is negative over there. If it is positive in that range, it must be positive. If nature of the derivative is of that type. So the function means f dash x, the right function is negative in the interval from 1 to 2. 1 to 2. So in that interval, the function is strictly decreasing, monotonically decreasing. So This is our correct option. Now, our next problem is in 0 less than x less than pi by 2, fx is equal to cos x minus 1 plus x square by 2 is, four options: decreasing, number 2 strictly decreasing, increasing, strictly increasing. Now problem is the interval is given 0 to pi by 2 and the function fx is given as that. So in that interval, this function is either decreasing or strictly decreasing or increasing or strictly increasing. We have to find it out. For that purpose, we have to find derivative f dash x is equal to derivative of cos x is minus sin x, 0. This is 2x by 2, that is plus x. So f dash x is that. Now it is not clear whether at all points within that interval it is positive or negative. For that purpose, there is a unique method. Let us take this is as let gx is equal to x minus sin x, that function x minus sin x. Let us see whether it is increasing or decreasing. For that purpose, g dash x is equal to 1 minus cos x. Now within that interval, I can say that this is positive. Why positive? Now cos x decreases continuously from 0 to pi by 2. At 0, it is 1. At pi by 2, this one is 0, so positive. And as because it is decreases continuously, so it is, I can say that it is positive. So gx is increasing function. So in that interval, x is positive, gx is greater than g0. What is g0? g0 is 0 minus sin 0 is 0. g0 is that is gx means x minus sin x, gx is greater than g0 is 0. That is x minus sin x is positive. So x minus sin x, this is positive. So that I can say f dash x is equal to x minus sin x, positive. Then we say fx is increasing, strictly increasing in 0 less than pi by 2. So fx is strictly increasing over there. Okay, next problem. Next problem is the function fx is equal to 4x to the power 4 minus 2x plus 1 is increasing, strictly increasing in, four options are there: 0 less than x less than 2, x greater than minus 1, x greater than half, and x greater than 0. That problem also given in West Bengal JEE in 2006. So here also the problem is very straightforward. One function is given, and in which interval of the following the function is strictly increasing. We have to find derivative. F dash x is equal to 16x cube minus 2. That is, taking 2 common, 8x cube minus 1. So it is positive. That function is positive if this is positive if 8x cube is greater than 1, that is x cube is greater than 1 by 8, that is x is greater than, just 1 minute, greater than half. X cube is greater than 1 by 8, so x is greater than half. So in that interval, the function is monotonically increases. So this is the correct option. So you see, always the problem is very straightforward. Now, let us take the next problem. The function fx is equal to log of 1 plus x minus x by x plus 1 is strictly increasing in number 1, x less than 0 negative, 1 less than x less than 2, 1 less than x less than 4, x positive. These are the four options where we have to find where this function is strictly increasing. Means derivative to be positive. The function can be written as log 1 plus x minus x plus 1 minus 1 by x plus 1. X plus 1 is there, that's why I simplify it. It is equal to log of 1 plus x minus this by that is 1 plus 1 upon x plus 1. So derivative is f dash x is equal to, derivative of that part is 1 upon 1 plus x, 0, and its derivative is minus 1 upon x plus 1 whole square. It is equal to, LCM is x plus 1 whole square. Here it is x plus 1 minus 1, so that x by x plus 1 whole square. Now to identify where it is positive. Strictly increasing means positive. For any value of x, denominator is positive because it is whole perfect square, whole square. So when numerator is positive, that is when x is positive, the derivative is positive, so increasing. So this is our correct option. So today is up to this. If you feel that this helps you, then like it, share it, and subscribe it. Thank you.